Hello students, in this lecture we'll discuss about total derivative of length element, area element and volume element which we'll use in further study. Total derivative of arc length. Let R be the position vector of a uh, point P with coordinates x, y, z in the curvilinear coordinate system. Therefore R is equal to x iota plus y j by z k. And if you transform it from Cartesian to polar, means we x y z and because x they are the coordinate system are orthogonal, x y z I j are orthogonal and u1 u v 3 are orthogonal. Therefore, we know that partiality of u v u1 u2 u3 and which is to x y z or partiality of x y z which is to u1 u2 u3 is known to means they are independent. Independent, then you can transform from Cartesian to curvilinear, curvilinear to particular. Okay, right? So substitute xy, make xy a function of u only. Substitute in this now this new which vector will be in the u2 u1 u2 u3, which is the position vector of point in this was the position vector point in Cartesian coordinate. This position vector point in curvilinear coordinate system. Now total derivative of r is given by dr is equal to, we know dr is equal to this 2 as a function of u1 u2 u3. The total derivative of r is equal to partial r is to u1 du1 plus partial r is to u2 du2 plus partial r is to u3 du3. And also know that partial r is to u1 is equal to h1 partial of r vector is to ui is equal to hi neutral to ei I just want to substitute the values. So this partial r is to u1, partial r is to u2, partial r is to u3. So in terms of H and HI and EIs, substitution we got dr is equal to h1 du1 e1 small e1 vector h2 plus h2 du2 small e2 vector plus h3 u3 h3 e3 small e3 vectors. Then the differential of arc length ds is given by. So the arc will be how will you get the length dr dot dr. So derivative of this is equal to this will get the differential of arc length. Dr is equal to dr dot dr. Now if we multiply dr dot we got ds square because they are small. Ds and dr they are comparable. This arc length and they are the position vector. So they are comparable. So ds in order to get ds square ds and because we are discussing vicinity of very close to point p, so length of the arc from p and the position vector point q with this 2p both are same. Therefore we can write ds is equal to ds dot ds or this is equal to ds and ds are comparable. Ds is equal to d dot dr dot dr. So this is equal to ds is equal to h1 square du1 square plus h2 square du2 plus h3 because they are the orthogonal system of vectors. That's known as that, right? If they are orthogonal, so we can write in the both coincide. The orthogonal tangential vector, tangential and vector both are identical. So we will write in terms of both of actually we write small. So further, after this, we'll consider this all these vectors because these vector tangential and vectors are identical. This term in terms of E1, E2, E3, this. Now let's find the arc length along the differential of arc length along the U1 curve. Along U1 curve, U2 is equal U2 and U3 are the constants. Means U1 curve is intersection of U2 is equal to C2, U3 is equal to C3 surfaces. So derivative of du2 is equal to 0. Derivative of du2 is equal to derivative of du total derivative u2 is equal to total derivative of u3 is equal to 0 because they are constants. Then the differential of arc length ds1 along u1 curve at point P is given by ds1 is equal to ds1 is equal to h1 square h1 d1. h1 square is equal to h ds1 square is equal to h1 square du square. Therefore h1 ds1 is equal to h1 d1. Yes, positive forces. Yes. Similarly, differential of arc length ds2 and ds3 along the curve along u2 curve and u3 curve at the point P is given by ds2 equal to h2 du2 ds3 equal to h3 du2. Definition of arc length ds1 ds2 ds3. Now this is the arc length. Arc length means we are doing this. And this is equal to this is the arc length ds1 ds2 and ds3. ds1 is equal to h1 d1, ds2 is equal to h2 du2. They from this to this, from P to this point, and this is equal to h3 is equal to ds3. Now let's find the area limits. Area limits. Let the area element d a1 vector is the area of the parallelogram formed by ds2 argument and ds2 ds3 found by ds2 and ds3 are lengths along the curve u2 du2 and u2 and u3. Now because the diagram is this diagram very small, so their arc length is along the arc, r is along this, r is along the this parameter. So this parameter is very small. This is magnified image of this is magnification of the this element volume at P, magnified image, so that we can understand the things. Otherwise, this is very small. As small as this parameter is as small we can take, right? So ds and dr are comparable. That's why comparable means length along the position vector along the components e1, e2, 3, and length along u1, u2, 3. They ds is a length along curve u1, ds2 along curve 2, ds arc length along u3. So they're comparable, right? Therefore, now let the area element dA1 is the area of the parallelogram formed by ds2 and ds3 are lengths along the curves u2 and u3. Therefore, area curve is equal to area is equal to this is the area of element area of this length. Okay. So this area is equal to this is a modulus of h2 e2 du2 h3 e3 du3. So h2 now h2. Which area this da1 area? Which one is this area? Da1 area is the along the curve. Which curves? Which curves? u2 and c2 curves. So this is u2. This is u2 curve. This is u2 curve. This is u2 curve and u3 curve. This curve and this curve. So with this length and this length, unit length. The component very small. Is equal to this length into unit vector along this direction. They're very small at point P, at this point. So this length along this unit vector, u2 curve, and this length along the u2 vector, this along this. So this element vectors. So the cross product area will be 24 this. Magnitude of this is equal to h2. So now the scalars will be taken outside. h2 du2 h3 du3 h2 du2 h2 h3 come common. Now this vector e2 into e3 is equal to e1. Vector is equal to 1. So is equal to area vector will be h2. This is area vector. Okay. H2 h3 du2. Similarly, du2 is the area element area is the area of the parallelogram found by ds1 and ds3. ds1 this is equal to ds1 h1 e1 d1 cross h3 e3 du3. So it's common and E1 plus E2 is E3 is equal to E3 E1 E2 E3 cross E1 is equal to E2. It is equal to 1. Here we can find E3 is equal to. So in D1 H1 D1 is not here. In DU2 H2 we have put simple such a way so that we can understand we can understand very clear. And these are elements of this faces. This face, double face, this face, down face, this face, and this face. These are parallels. These are elements. This element, this element, this front and back. Beyond this. Now volume element. The element of arc length ds1 along u1 curve at P is given by ds1. Same along this is equal to arc the element of arc length ds1 along curve u1 at point P. At this point P is given by this one. Vector E h1 d1 into 3. This one. And this is along because this is along s2. h2 du2 h3 du3 into unit vector. This is rate of change of the this is change vector ut. This is the rate of change of change vector and along the du direction. So this is similarly the element of arc length ds2 along the curve arc length ds2 along the u2 at point P is given by this, and the element of the arc length ds3 along the curve u3 curve at point P is given by this. So volume is therefore now the volume of the volume element dV is the volume of the parallelepiped found by ds1, ds2, ds3 is the scalar triple product. Triple product. So these three vectors and is equal to now scalar outside A dot B cross C. So vector E1 dot E2 cross E3 scalar will be taken outside. So E2 cross E3 is equal to E1 vector dot E vector is equal to 1. So it is equal to D H1 H2 H3 D1 D2. Thank you.